Imagine you spent your entire childhood being told the solar system had 9 planets. You memorized them in order. You built a model out of styrofoam balls and painted rings around Saturn with a cheap brush. You said the names like a little prayer: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. And then, one day in 2006, someone held a vote. And, just like that, Pluto was gone. Now here is the question nobody really answers properly. Was Pluto always not a planet? Or did we genuinely get it wrong for 76 years? And if we got it wrong, what does that say about the way science works? About the rules we make and the rules we are willing to break? The story of Pluto is not just about a small icy rock at the edge of the solar system. It is about ambition, professional politics, hurt feelings, and what happens when the universe turns out to be far stranger and more complicated than we expected. To understand why Pluto lost its planet status, you have to go back much further than 2006. You have to go back to the 1840s, a time when astronomers were still working with handwritten calculations and telescopes the size of small cannons. In 1846, the planet Neptune was discovered, and the way it was found was genuinely remarkable. Mathematicians had noticed that Uranus was not moving exactly the way it should be. Something was pulling on it. Something big. Using pure mathematics, no telescope, just pen and paper, they predicted where a hidden planet had to be. And when astronomers pointed their instruments at that exact spot in the sky, there it was, Neptune, hiding in plain sight. This was a triumph of prediction, of science working exactly as it is supposed to. But even after Neptune was accounted for, Uranus still seemed to wobble just slightly, just enough to make certain astronomers suspicious. Maybe, they thought, there was yet another planet out there. A planet X. Something even further away, even colder, even darker. Something waiting to be found. That obsession, that specific, almost romantic obsession with a hidden 9th planet, is exactly what led to Pluto. Enter Percival Lowell, an American astronomer, a man of considerable wealth and even more considerable confidence, who had already made himself famous or perhaps infamous by insisting that Mars had canals built by an intelligent civilization. He was wrong about that. Spectacularly wrong. But his passion for finding things that might or might not exist led him to build his own private observatory in Flagstaff, Arizona, and dedicate a significant portion of his later life to hunting for Planet X. Lowell died in 1916 without finding it. His observatory carried on the search. And then, in 1930, a 24-year-old farm boy from Kansas named Clyde Tombaugh sat down at a machine called a blink comparator, a device that rapidly alternates between 2 photographic plates of the same region of sky, and spotted something that had moved. Something small. Something there, in the dark, where Planet X was supposed to be. The announcement hit the world like a thunderclap. Headlines everywhere. The discovery of a new planet. An 11-year-old girl in Oxford named Venetia Burney suggested the name Pluto, after the god of the underworld, because the name started with the letters P and L, which were also Percival Lowell's initials. The suggestion was passed along, accepted, and the name stuck. Pluto. A world at the edge of everything. And so, for the next several decades, Pluto sat comfortably at the end of the planetary lineup. There were 9 planets, textbooks were printed, posters were made, school children memorized the order, the solar system felt complete. But trouble was already brewing, and not slowly. Almost immediately after its discovery, astronomers started realizing that Pluto was odd. It was tiny, much tinier than anyone had expected. Early estimates suggested it might be as large as Earth. Then, the estimates shrank. And shrank again. By the 1970s, it was clear that Pluto was smaller than our own moon, and its orbit was strange, tilted, elongated, crossing inside Neptune's path at certain points. For 20 years out of every 248, Pluto is actually closer to the Sun than Neptune is. Not very planet-like behavior, it has to be said. So here is where we need to pause and ask a fundamental question that sounds simple, but turns out to be surprisingly slippery. What actually is a planet? You might think this is an obvious question with an obvious answer. A planet is a big round thing that goes around the sun. But big compared to what? And how round is round enough? Before 2006, there was no official scientific definition of the word planet. None. The International Astronomical Union, the governing body for astronomical naming, had never formally defined it. The word had been used for thousands of years, from the ancient Greek word planets, meaning wanderer, referring to any celestial object that moved against the fixed stars. For most of human history, the sun and moon were considered planets. Earth was not, because nobody thought we were moving. Think of it this way. Imagine you are sorting a pile of rocks. You have giant boulders, medium rocks, pebbles, and grains of sand. At what point does a pebble become a rock? There is no clean line. The categories we use are human inventions layered on top of a natural spectrum. The universe does not care about our labels, it just keeps making things of all different sizes. For decades, that fuzziness did not matter much. There were 9 obvious candidates, and nobody was seriously questioning any of them. But then technology improved. Telescopes got better. Computers let astronomers survey larger and larger sections of sky. And slowly, the outer solar system began to reveal just how crowded it really was. The region beyond Neptune, now known as the Kuiper Belt, turned out to be swarming with icy objects. Not just a few. Hundreds. Thousands. Objects that were, in many cases, not dramatically different in size from Pluto itself. The solar system's edge was not empty space with one lonely outpost. It was a whole neighborhood. Pluto was not the last planet. It was, depending on how you looked at it, just the first and most prominent member of an enormous family. For a long time, many astronomers were willing to let sleeping dogs lie. Pluto had been a planet for 76 years. The public loved it. Kids learned it. Why make trouble? The assumption was that Pluto was genuinely unique, that it sat out there in lonely distinction, bigger and more important than the icy debris scattered around it. That assumption was probably always more sentimental than scientific, but it held up reasonably well. Until 2005, when an astronomer named Mike Brown and his team discovered an object they initially nicknamed Xena, and which was later officially named Eris. Eris, it turned out, was actually slightly more massive than Pluto. Not larger in physical size, we now know Pluto is marginally bigger in terms of diameter, but denser and heavier. If Pluto was a planet, Eris was a planet too. And if Eris was a planet, what about the other large Kuiper Belt objects? Makemake? Haumea? Sedna? Where did it end? Were we going to add new planets to the list every few years? Would schoolchildren in 30 years be memorizing 17 or 22 planets? The International Astronomical Union faced a genuine crisis. They could either expand the definition of planet to include potentially dozens of objects, or they could tighten it in a way that excluded Pluto along with the newcomers. There was also a third option. Do nothing and let the mess continue, which some scientists actually preferred. Science, after all, is comfortable with ambiguity. It is humans who hate it. The showdown came at the EO General Assembly in Prague in August 2006. It was a gathering of thousands of astronomers from around the world, assembled every 3 years to discuss the business of the cosmos. Most of them were not planetary scientists. Many of them were there to talk about distant galaxies, black holes, and stellar evolution, things that had nothing to do with Pluto. And yet they found themselves voting on the fate of the solar system's most beloved small body. The debate was heated, passionate, and by the standards of astronomical conferences, almost theatrical. There were competing proposals. One draft definition would have made the solar system larger by adding Eris, Ceres, and Charon as full planets. Another would have kept Pluto but required very specific language about what planet meant. The definition that ultimately passed by a show of hands on the last day of the conference stated that a planet must do 3 things. First, it must orbit the sun. Second, it must have sufficient mass to achieve a roughly spherical shape. And third, this is the critical one, it must have cleared the neighborhood around its orbit. That third criterion is what did it. Clearing the neighborhood means that a true planet, over the course of its orbital history, has either gravitationally absorbed the other objects in its zone, flung them away, or captured them as moons. Jupiter does this magnificently. Earth does it. Even tiny Mercury does it. Pluto does not. Pluto's orbit is shared with thousands of other Kuiper Belt objects, and Pluto does not have anywhere near enough gravitational influence to dominate that region. By this definition, Pluto was reclassified as a dwarf planet, a new category created that same day that also includes Eris and Ceres. Only around 4% of EO members voted. Of those present in Prague that day, the resolution passed. The solar system officially had 8 planets, and Pluto, after 76 years, was demoted. So, why did Pluto really lose its planet status? The honest answer is a combination of science, timing, and the very human need for categories that make sense. Scientifically, Pluto was always an outlier. Its small size, its tilted and elongated orbit, its position within the Kuiper Belt, none of these characteristics fit the mold of a classical planet. We did not know this when Pluto was discovered in 1930 because we did not have the tools to know it. We did not know the Kuiper Belt existed. We did not know Pluto was so small. We were working with incomplete information and doing our best, which is, to be fair, all science ever does. The timing came from technology. Better telescopes in the 1990s and 2000s opened up the outer solar system in ways that earlier generations could only dream about. And what they found was a zoo of icy objects, with Pluto sitting among them rather than above them. The discovery of Eris forced the issue. You could not keep Pluto and exclude Eris without looking arbitrary. And, if you included both, the floodgates opened. The politics were real too. The EO vote was contentious. Many planetary scientists, including Alan Stern, the lead scientist on NASA's New Horizons mission to Pluto, were deeply unhappy with the result. Stern argued that the definition was flawed, pointing out that under the clearing the neighborhood criterion, Earth itself would not technically qualify as a planet if you moved it to Pluto's distant orbit. The definition, in other words, is partly dependent on where you are, not just what you are. And public opinion was devastated. Within days of the announcement, the internet was flooded with protest. School children wrote letters. The state of New Mexico, where Clyde Tombaugh had lived and worked, passed a resolution declaring that within its borders, Pluto would always be considered a planet. Illinois followed. Grief, it turns out, does not care much about astronomical technicalities. Here is what is genuinely interesting about the whole Pluto episode looking back on it now. Science reclassified Pluto not because Pluto changed, but because our understanding of it changed. The object itself has always been exactly what it is, a small, cold, geologically active world with a thin nitrogen atmosphere, a giant moon in Charon, and a surface covered in mountains of water ice and plains of frozen nitrogen. When NASA's New Horizons spacecraft flew past Pluto in July 2015, it sent back images of breathtaking detail and beauty. A heart-shaped nitrogen glacier, towering ice mountains, a hazy blue-tinged atmosphere at sunset. Whatever you call it, planet, dwarf planet, Kuiper Belt object, it is extraordinary. The demotion of Pluto is sometimes used as a cautionary tale about the hubris of science. They got it wrong for 76 years, people say. How can we trust them? But that reading misses the point entirely. The reclassification of Pluto is actually science working exactly as it should. New information arrived. The old categories did not fit anymore. Adjustments were made. That is not a failure. That is the whole system functioning correctly. The willingness to revise, to say we know more now, is a strength, not a weakness. Pluto is still out there. It has not moved. It has not changed. It still takes 248 years to complete one orbit around the Sun. It is still, by any reasonable measure, one of the most fascinating objects in the solar system. The word planet no longer applies to it under the current definition, but definitions are tools, not truths. They are useful until they are not, and then we make new ones. And somewhere in a box in New Mexico, there are photographic plates from 1930 with a tiny dot on them that a 24-year-old farm boy spotted because he was patient and careful and paying attention. A dot that started a conversation the human race is still having nearly a century later. That seems worth something. whatever you call it.